Welcome to the Webcast Wednesday session presented by National Instruments. Basically, at the time of my demonstration, if you want to ask any question, if any question sprouts in your mind, then we have an application engineer side by where you can put up your questions in this respective board and the question will be answered. So how to connect? If you are using video over internet protocol, in that case you just need to turn up the volume on your PC or on your laptop. For people who are using the telephone, for people who have a slow internet connectivity, in that case what you can do is the India attendees can dial up this number 1-800-425-4061 and you have to enter the pin that is displayed in the screen right now, 507248#. Okay, so let's start with the session today, and today we are going to present what is called as image processing. So we are showing image processing using LabVIEW. Let me introduce myself first. I'm Nilotpal Chaudhary and I work as an applications engineer at National Instruments. So let us start off with the session today. It will be quite an interesting session where we'll discuss the different aspects of image processing and how we can implement it in the LabVIEW environment. So let us first go ahead and discuss the blueprint of NI vision. So we have three steps particularly: image acquisition, image processing, and image analysis. So image acquisition, as the name suggests, is basically the way we acquire the image. So NI provides a lot of cameras, a lot of development environment for acquiring the image. So to name a few, SmartCam of 177X series basically has an inline processor also. Again, we also have third-party support cameras like that of the Basler. We have GE cameras, IEEE 1394 standard cameras, and so and so. So this is basically used, all these cameras are basically used to acquire the images. Now the second stage is the image processing. So the image processing is a kind of a technique, or is like a signal processing for which the input is an image and the output is an image or a set of characters or the parameters that define that image. So basically we need the image processing step in between such that we can prepare our image or we can condition our image for the image analysis. Now the image analysis that we do is basically to have a view, or to be more descriptive, we need to analyze the parameters of the image in order to feed it into machine vision, in order to feed it into motion control, and different specs. So basically these are the three main steps that you need to follow while you are working in NI vision: image acquisition, image processing, and image analysis. So let us go first with the image acquisition. So there are two types of acquisition. Namely, there are two types of acquisition. Firstly, it is called as a snap, and the second is called as a grab. Now a snap is just like a snapshot. It's just like a still photo that we take in our cameras. So what happens, what is the process that is executed when an image is acquired by the camera? The first is you have a processing buffer. When you are taking just a snapshot, you have a processing buffer. So just an image is captured by the camera and it is then fed to the processing buffer. When you are acquiring it continuously, or when you are grabbing the image continuously, you have an intermediate acquisition buffer, as you can see in this slide. Okay, you have an acquisition buffer wherein the frames will be fed to, and then after you stop the acquisition, the last frame of the image will then be put into the processing buffer for further processing. So in snap and grab, the difference is the snap is used for one image, one single frame of image, and in grab is used for continuous acquisition of image, wherein the last frame of the image will be acquired in the processing buffer. Okay, let's move next. The next is basically, this is a slide which describes you the different functions that are there in the LabVIEW environment, which you can use for using the snap or the grab operation. So this snap, IMEC-DX snap, will acquire an image from the device and writes it to a buffer. The IMEC-DX grab will retrieve an image from device and write it to a buffer. Now, what if you want multiple frames of the image? Suppose, for example, you have a 30 FPS camera, and the camera, that means the camera is capable of acquiring 30 frames per second. What if you require all the 30 frames in 1 second? In that case, you require multiple buffers. So we have something called as a sequence, which is just a superset of grab. A sequence is a one-shot acquisition of multiple frames into multiple buffers. Okay. All these three parameters will be demonstrated to you in the later part of the demonstration. Okay. Now let's move to the next slide. Let's discuss the ExpressVIs. So before discussing this, I wanted to give you a brief analysis of what we are going to do. So this is a metal sheet, okay, and this is a metal sheet, and these are the metal particles. So what we are interested in is to analyze this circular metal particles. So if you see the image is not yet ready for an image analysis. Okay, so we need first to condition or process the image in a way such that we can analyze the image. There are certain unwanted information appended with the image, which we need to eradicate such that we can have a better image analysis, a correct image analysis. Okay, so let us first discuss the Vision ExpressVIs. So there are two kinds of Vision ExpressVIs. The first is the Vision Acquisition, and the second is the Vision and Assistant. The Vision Acquisition ExpressVI configure your snap or grab, will simulate the acquisition without any hardware, test your camera and acquisition attributes. So basically, this Vision Acquisition software is nothing but a way of acquiring the image by using a configurable dialog box setup ExpressVI. So in this ExpressVI, you can configure a snap, you can configure a grab as well. Also, if you are basically trying to do an image processing in a preoccupied or a predefined image, in that case you can just simulate an acquisition without any hardware. We can also test our camera and the acquisition attributes and parameters. Even the camera parameters can be tested in this Vision Acquisition. Next we have the Vision Assistant. So see, basically there are two ways of opening or using the Vision Assistant. One, we can use it from the LabVIEW environment, or the other, we can just start the Vision Assistant as a tool from the start menu. So basically the Vision Assistant is used to access, it gives an access to most functions from the Vision Assistant, quickly and easily viewing of results of different processing functions, easily configurable ExpressVI interface. So in a nutshell, Vision Assistant provides you with a way of developing your script for your algorithm. So you can have a fast analysis of the algorithm by using a Vision Assistant. Because in Vision Assistant, we write just a script wherein the algo is put in the form of certain scripts or certain steps. So we'll go to Vision Assistant and we'll also see how the Vision Assistant is used for prototyping our application. Now let's go to image processing, which is the second step. Now the image processing consists of all these functions, basically the filtering, morphology, color processing, operators, frequency domain analysis. So these are a few to name, but these are the very basic and very generic ones. So today I will discuss a few of them which will be required in our demonstration in the VI that we will develop. So the first one that we'll require is filtering. So let us have a brief about filtering. So why we need to filter images? So if you see on the left side, you have an image which is quite blurred out. Now this image is not good to be used for image analysis. In this case, what we do is we try to sharpen the image. In that case, we use sharpening filters or convolution filters. Again, if for example you need to smoothen your image, you need to smoothen the contrasts that exist in the edges, or you need to change the detailing of the image. In that case, you can use either a smoothening filter or a sharpening filter. Now, at the same time, in the environment, depending upon the environment in which you are acquiring the image, there might be certain informations which are appended to the image, but it is not necessary. Those are called as the noise. This is a basic definition of noise. So we need filter to remove the noise as well. Now, when we are using a filter, we require to define something called as a filter kernel, or even in some terminologies it's called as a mask. So this filter kernel is used basically to filter the entire image. You can either use some predefined filter kernel which is defined in the LabVIEW environment, or you can create your own filter kernels. Okay, this is a brief idea about filtering. Of course, there are different filters that you can use in LabVIEW. Now let's go to morphology. Now, as the word morphology suggests, that it has something to do with the structure. And when we say structure of the image, we basically mean the information that is there in the image. So this is basically used to perform morphological operations on an image. So what are the basic morphological operations that we do? Dilation and erosion, right, on grayscale and binary images. Now, there are other ways as well which is used to improve the quality of the binary images by filling holes in particles. Now, if you see the previous slide, here you see that there are certain border images, right? There are certain border informations. This is what I mean. These are some border informations which we don't require. So a morphological operation can be executed to remove this border operations, or sorry, this border information. Again, if you see here, there are certain holes in this particles. So these holes might create a problem when we are doing a particle analysis. So we need to fill up the holes as well. So the way of filling up the hole is something to do with the structure of the image, with the information of the image. So what we do is we basically fill up the holes such that it helps us in the image analysis step. Again, we can also use morphological BIs for removing particles that touch the border of an image as described, removing noise particles, removing unwanted particles based on different characteristics of the particle. Okay, these things will get more clear when we do the demonstration. You all know about thresholding, right? So thresholding is basically a way of converting a grayscale image into binary image, and a binary image consists of only ones and zeros. So how does a thresholding take place? It's very simple. We define a threshold level or a gray level. Now, if any pixel is less than that threshold gray level, we put the pixel, we map the pixel value as 0. And for any pixel value which is greater than or equal to t, or equal to the threshold gray value, that is mapped to 1. That means you have only 2 pixel values, zeros and ones, depending upon the previous pixel values. Thresholding is very much necessary because most of the morphological operations are done in the binary images. Now let us come to the image analysis. Now there are different ways of doing image analysis. One way is a particle analysis. This particle analysis returns information about the contents of grayscale and binary images as well as the particles in the image. So this will give you the different parametric approaches, the different parametric measurements that pertains to a particular particle. It also retrieves the pixel information and statistics along any one-dimensional profile in an image and detect and measure particles in binary images. So this basically gives you a thorough picture of how the entire image information is bundled about. So let us then move to a demonstration of how we can acquire the images in LabVIEW. So I have a webcam that has been interfaced with my laptop. Okay, so that webcam is of Logitech. Now this is very simple. We go to the Vision and Motion palette, we ping it. We go to the Vision Express. There we'll find 2 VIs. One is the Vision Acquisition and the other is the Vision Assistant. So we'll just drag and drop this. When you just drag and drop this, a dialog box will appear. So this is initializing, the dialog box is initializing. Okay. So the dialog box will appear like this. Okay. Now the camera which are interfaced with your system will appear here under IMEC DX. The reason why this is appearing under IMEC DX because when we're using a webcam which is direct show compatible, in that case they're accessing the IMEC DX drivers. For that, these are appearing across IMEC DX devices. Now, very simple, we go to next. Here we will just have one single acquisition, right, with processing. So we'll just select single acquisition with processing. After that we select next. These are the different attributes to test. You can test it here. You can test the image here. So you can see the image here. Next we go there. So there is an option of saving the image as well. Right now we are not concerned with that. Again, the next is how to select the controls. What are the controls and indicators that you require to output from the ExpressVI, and then we select finish. So after this, we'll just click on this, and it appears. So you can see a different products of vision basically that we provide. So the product that you see here is a smart cam overnight with an inline processing processor. It's a very fast processor. At the same time, it is extremely rugged and can be used in any environment. Again, we have something called as the EVS. This is basically an embedded vision system, which is used particularly for vision applications. It has a processor, and it has all the interfaces that you require for interfacing different types of cameras, any type of camera. This is basically a camera which we call it as a GIGI camera. So this GIGI is basically connected through a crossover or Ethernet cable. So this is basically used when we are doing low-level applications. Again, this is called as a CDO, which is a kind of a platform that we provide. Again, let us see the grab function. So as I explained to you, grab will continuously acquire the image, and when we stop it, only the last frame of the image will be acquired in the acquisition buffer, and then it will be passed to the processing buffer. So how we do that? Very simple. We just, similar to that, we just go to the vision acquisition palette, and then we place the vision acquisition ExpressVI. It's just initializing. It takes a little time to initialize. Yeah. So it has initialized. So the camera that we're using is definitely Logitech QuickCam Orbit Screen. Then we go to next. What we do is, now we select continuous acquisition with inline processing. Then we just test the device, see whether it is detecting or not, and it is detecting continuously. We stop it. And then we go to next. This is something that is used for image logging. We press next, and we have all this required out controls and required indicators. So we selected, these are by default selected, and with the optional indicators that I selected is image number, which will give the number of frames that has been captured, and this will give the frame rate, basically an attribute of the camera itself. So we press and finish. After that, when I move it, so basically it's acquiring continuously, as you can see, like this and this. This is continuously acquiring the image, right? Okay. I give you a better view. This is continuously acquiring the image, and the image number is increasing, and the frame rate is 10 point, now it's 9.28. Okay, we stop it. So this is a very simple and perhaps one of the best way of acquiring the image, and more easiest way actually. Okay, now let us move to the VI that we want to develop. Firstly, what we'll do is we'll bring one image, the vision acquisition palette. So how we'll find that? Let us go from this graph, vision. We'll go to vision and motion palette. We'll bring this from here. We'll go to Vision Express. Yes. So this is my vision acquisition. Now here I will not acquire an image. So my image is already there, right? So what we'll do is we'll just take the image, the already available image, and then we will process the image and analyze the image. Okay. The image processing and the analysis will be done in the Vision Assistant. So you will select the image from the folder, right? So just select the folder option and then give the path. So right now it is selected in the desktop. Press OK, press the image once, done. Next. So only thing that will be used as an indicator is the image out. So we press in finish. Right? You can see the front panel once. So this is the image. Now we go to the Vision Assistant and put it across here. So the Vision Assistant is initializing. Yes. So we have the Vision Assistant also with us. Now what we'll do is we will first filter the image, right? For that we'll go here, take a filtering and do the convolution, highlighting details. So you can see here, right? This is the similar image what I've shown in the slide and what you're seeing right now in the Vision Assistant. So this image is a bit blurred out and it's not good enough for image analysis. Now once I use this convolution filter, the details of the image gets more prominent. As you can see, it has become more sharpened. The details have become more sharpened. For this we require this convolution highlighting details. Depending upon your application, there are different filters that you can use. So you need to have the theoretical concept clear in order to decide which filter to use. Okay. For the time being, I'm using a convolution filter, and the mask that I'm using is this. So this is the kernel that I'm using. Okay. Press OK. Simple. After that, we will threshold the image so that we can use the morphological operations. For that, what we'll do is select this. So the image that we have is a grayscale image. So we'll use this, and we'll put the minimum threshold value to be 130. That is one of the standards that we use. Okay. Put OK. This is now the binary image. So the red part signifies the pixels with 1 and the black with 0. After that, we will go to the morphological operations and we'll select advanced morphology. So now the first morphological operation that I want to do is to remove the border objects. So as you can see here, the border objects is deleted. So press on OK. Again, we'll go to the advanced morphology and as you can see here, the particles are not filled up completely. So they have some discontinuities inside of that particle. So what we'll do is we will fill up the holes here. Okay. So when we fill up the holes, what happens is the entire discontinuity disappears. This basically signifies that there has been some interpolation that has been done within the pixels. Okay. After the advanced morphology that we did for the filling up the holes, what we'll do next is we will do a particle filtering. This particle filtering will help me to eradicate this oblong particles, this elongated particles, and have only this circular particles. Okay. So the analysis that I want to do is basically the analysis of this circular particles. So I have to find out a way in order to remove this elongated particles. How will do that? We'll use a particle filter. So in that particle filter, these are the measurements that you can do. So depending upon your requirement, you can select your own measurements. Right now what I'm doing is I'm selecting an option which is called as Haywood circulatory factor. What this do is it calculates the ratio of the perimeter of the particle to the perimeter of the circle with the same area. The more circular the particle, the more closer the ratio is to 1. Okay. Now this parameter range is basically the range of the circle that you want to include in your image. For that, what we'll do, we'll just change the maximum and the minimum value of this parameter range. Here I put it as 1, and here I put it as, this is just by hidden trial method, so we put it as 1.06. See this. So what you want to do with this, you want to keep this, right? You want to keep all the circular particles, you don't want to remove them. So if you say remove, it will give you all the oblong particles, the elongated particles. If you keep, it will keep the circular particles. Okay. So the basic Hayward circularity factor function is to calculate the ratio of the perimeter of the particle to the perimeter of the circle with the same area. So the closer the particle is to the circle, the ratio will be tending to 1. And we place here keep as an action because we want to keep the particles, and we press OK. After that, it's a very simple process of using the particle analysis. Here we just use the particle analysis when there is nothing to configure here. So the number of objects that have been discovered is 37. Okay, and you can select the measurements. There are different types of measurements that you can do. What I'll suggest you is to deselect everything now and select a few, like the center of mass, center of Y, center of mass of Y, and then a rectangle, left, top, right, bottom. Okay, done. So our image processing and our image analysis is almost done. We need to select the controls now. We'll select just two, number of particles that we have detected, that is 37, as you can see in the particle analysis step, and this is the particle measurements that we have selected. Okay, and we press finish. Now we connect this image in to this image out. This are the indicators. Okay. Now when I run this, we need to change it to snapshot such that it is available. So as you can see there, the number of particles that has been detected is 37, and these are the measurements that we have done. So what does this signify? The row signifies the different particles, and the column signifies the different parameters that we have defined. Okay, the different parameters that we have defined. So as far as I remember, we have selected the center of mass X, center of mass Y, and the bounding rectangle left, top, right, bottom. So this has given you all the images. So this is a basic idea. We want to present a basic idea as in how we do image analysis, image processing, image acquisition in LabVIEW. So I hope this has been helpful to you. Move to the next slide. So we have already demonstrated you the demo. So the contest of the week this time is this. We want you to find the length of the rod. Okay, so this is an image which will be shared to you. Okay, what you need to do is a very simple 3-step thing. You first need to acquire the image, or in a sense you need to simulate the image by using the Vision Acquisition Express VI. Then you need the Vision Assistant. There you need to do two things. One is detecting the edge, okay, detecting this edge and this edge. Okay, once you detect this edge and this edge, there is a step called as the caliper, which you will find in the Vision Assistant if you thoroughly search it. Okay, this I leave it to you to search this caliper step. And once you detect this edges, all you need to do is to use the caliper step. The caliper step will then give you the length of the rod. This is a very simple application that you can develop for measuring the length of the rod. So the contest of the week that is open now, and we request all the enthusiasts to participate, is find the length of the rod or find the length of the rod of the image that has been given in the link below. Hence, use edge detection and use caliper. So caliper is basically a step that gives the distance between 2 points in an image. Okay. So extended learning and participation. Just give a try to watch the previous episodes of Webcast Wednesday. Get your queries from the sessions and LabVIEW resolved. Interact with your peers and industry experts. Participate in weekly contests here and win about 50% discount in CLAT and other national instrument certification examinations. And if you attend 20 webcast sessions, you will win a free CLAT attempt. So you can watch the recording of the session and participate in the contest of the week. There are 2 steps for doing that. 1, you visit the www.labviewenable.in. Step 2 is click on the Webcast Wednesday graphic you see as you land on the page. So thank you very much for attending the session. So the old webcast is available in the archives. Contest link you can see on the chat, which is now active. Okay. We are open now for discussion for 5 to 10 minutes. If you have any question, you can just direct us. Okay. Thank you very much. It's Nirpal Chaudhary. I will be there for 5 to 10 minutes to answer your questions. Hope to see you again in the next Webcast Wednesday. Thank you very much.